Hello, this is Clam from 3D Palace, and today I want to talk to you about a very powerful feature in Terragen, which is the importing of satellite imagery and creating a relief map from that to bring out a more realistic feel to your renders and your terrains. One of the neat things about that is also you can take that same data and convert it into TGA format and move that into your favorite paint shop program and create different layered effects in there. Custom brushes. I can see all sorts of mayhem happening. And then move them back into your favorite terrain generation or visualization software. And, well, let's get started and start talking about the files that we need to work with here. The very first, we've got what are called DEM files, which are digital elevation model files, and they come in different depths of resolution. Some of the best ones are the 7.5 minute 1 to 24,000 scale model, which is a land parameter of 30 by 30 meters. And then there's a 1 to 250,000 scale DEM, also known as a 1 degree, and it has a resolution of 90 to 90 meters. These DEM files are imported into Terragen with a conversion program called 3D DEM. There are several conversion programs out there, and we may talk about some of them. 3D DEM I have found to be the best and easiest to work with. There are some other conversion programs for very, very specific satellite data conversion and retrieval. It really depends on what data you can get your hands on and what conversion programs you're going to need to run to get the data converted for import into Terragen. Most of the data that you're going to find for real-world images can be located off of quad maps, and those are USGS data quad maps. So if we know where a place is, we can then look it up on a quad map. And since seeing is believing, well, here, let's look for a quad map. Today I've chosen Devil's Tower as our place, and I want to do a resolution of that, or a rendering. And I'm here, I've Googled out some information, and the information I've Googled out is it's telling me that Cook County is where Devil's Tower is located, and so what we need to do now is find the elevation quads for Cook County, and we can do that from the USGS. There's several sites that break up these quads, but this one here is a great one. You do need Adobe Acrobat Reader for it, and you go down and choose your quad, or choose your state, and I think I got one open here. And when you open it up, you'll see, well, here's Wyoming, and each county is broken down into quad maps. And we're going to zoom in here, and you can see after I've zoomed in, we actually do have there's Devil's Tower there in the background, which happens to be a interesting landmark in Wyoming, and there's the name of the quad map is called Devil's Tower. Well, this is 30 meters by 30 meters in land, and what you're going to find out is it may not be enough to get the camera angle shot that you want. So what you're going to do, and what I've done, is you're probably going to want to download the surrounding quad maps and stitch them together to make one big map, so that from that you can choose what terrain you want to work with. And what I've done here is I've written down all the maps that I need to download so that I have a list of them. And basically they're just the maps in the surrounding area. And then you're going to go to a download source. There's two distinct areas or places, maybe three different ones to download. Geo Community, geo.com is free. All you have to do is register. And when you go to the DEM, USGS DEM download, what you get here is a map right now of the United States, and you go to Wyoming, bring that up, you get basically all your counties. After that, you get to choose different mapping types, and for what we want to work with is the DEM elevation data. And then you get all of the quads for that county. And so you basically go through and systematically download all your maps from your list and save them to a folder. And what's nice with that DEM data there is that it is importable from the FEO plugins that we added earlier right here. And we can unzip those and import them directly into Terragen from there. One of the bad things about I'm using Mozilla, and what Mozilla does is it adds a .txt to the end of those files, so you have to go through and manually open those up and change them. And as you can see here, I've got the files open and I have to go through and manually change them off. One of the more annoying features of Windows. Okay, and what you see here is I've got them all done now, and they're stored in a Unix compression, double compression format, tar and GZ. So you're going to need a compression program to unzip them, or if you're using the 3D DEM, which I'm going to be showing you here, you don't need, and it's already built into 3D DEM, so you only have to process them to this level here to get them stitched together. So okay, now let me show you the second way to get terrain data, and that is from the USGS NED repository, which is a seamless national elevation data set, and it's a seamless, what they call a seamless data set. And let's take a look at this. It has a web interface, and what you get here is a national map. These are how you move around your map, and you can zoom in and zoom out and create selection areas. There's a great little help function on it. Let's click Wyoming. Let's look over here for a second. These are our layers that are on top that we can view. And we want to see the NED. 1/3 is the higher resolution one of the NED and newer data set compared to the 1.9, and if you can get either one of those, that'd be fantastic. I'm going to turn off the NLCD 92 data set. Scroll down and see what else we have. I'm going to turn on the SRTM, which is the shuttle mission that mapped the planet in, I do believe, 2000 and 2001. We have different layers that we can see and hide. I'm going to turn off the transparent layer. I'm going to leave on the shaded relief. Refresh the map. Okay, there we go. And I want Wyoming, and I do believe, let's see, Nebraska, Wyoming. Zoom in here. Okay, and we're zooming in, and I think Devil's Tower is right in that area there, so we're just going to zoom in until we get there. That's the view at 18.9 miles looks like. And there's our target area. Fascinating. Now what we want to do is click our download selection, and I'm going to take a sample. Selection to be downloaded or ordered on media. Okay, we've made our selection set, and we've clicked it. Up comes another window telling us we're processing. This may take a few minutes. Okay, after the data set has been created, we have different formats here. We have a 1/3, which is what we want. And we have the normal NED and the SR, TM, and 30. What we want to do before we decide to click any of this is we want to go to the modified data set. And here we have the ability to change some information, and what we want to do is change them to TIFF. These are all different imports, and Terragen doesn't support most of them, although there is a conversion for the bill, but the TIFF is the very best here. And we want to scroll all the way down and save our changes and return to summary. There we go. Now you can see that the data sets now have TIFF format. And I'm interested in downloading, that's size 7 megs. And I've been added to a queue, so it's going to take a few minutes, and we'll be right back. Okay, and what it gives us is, after it's completed making the zip for us, it gives us a file name, and I'm going to change this. And it downloads. It's as easy as pie. Well, let's go to 3D now and take a look at it. It's a fantastic freeware program that does a lot of conversion techniques and opens a lot of files. So let's load a terrain model, and here we have a lot of different terrains to utilize. We have the USGS DEM, which is the first selection sets that we downloaded. The second one that we did from the Seamless NED, we would be using the GeoTIFF, and I'll show you those also. So let's go to the USGS DEM, and here we are. Let's open up one of them. And when the model opens, we have this, which is our quad map, just one of them. We have our longitude, elevations, and latitude, so we can find out. We have a little selector, which if we grab the corner, we can drag and make bigger and spin around, which we'll be using that a lot more later on. And let's go to operation, and we're to look here. We have an overhead view where we are now. We can have a map overlay if we wanted to show populated areas, if we had a actual quad map of the area of the civilian populations or whatever we wanted to show. Let's take a look at the 3D scene. We can leave everything pretty much default right off the bat, and we've got a nice 3D shaded representation of what was in our square, our selection square. We can modify the colors on the map. We can apply another map overlay. Resize overhead view. Select a smaller area. We're going to be using this later on to scale our maps and our selection sets to real-world coordinates in Terragen, so that we can keep the same detail level when we export our terrains out. But exporting a terrain from a DEM map is as easy as going to the file and choosing save as a terrain, and we can either save the entire terrain or save a selected area. And if we go into our operation sets, and change our area to 256 or 252. And select an area. There we go. We'll bring up Terragen. Okay, go to Open, and here's our test export. Just opened it up. Let's double check our size. And open up a render preview. Turn that up. There we go. Let's get perhaps a different angle on it. And there we go. Well, we have new terrain basically from satellite elevation data brought into Terragen. Yeah, let's try taking that to 100 feet. Whoops. 100 meters is too big. How about 10? Yeah. 5. Well, it looks like 1 meter really did us well here. Let's render off a preview. And voila, real-world height data imported into Terragen. Okay, let's clear that out. There we go. Open up our 3D DEM. And let's take a look at what other data we have to load. Okay. And let's open up the NED 13 TIFF and take a look at it. Ooh, much higher resolution than the other one. And that's why the seamless data can be much more interesting. Let's get a 3D representation of that square there. There we go. Well, that's the 3D scene there from the NED resolution. Unfortunately, to say that's not the actual geological formation I was looking for. But let's take a look at the other TIFF. And you can see another distinct resolution difference there. All of these are pretty interesting. You got to play with what you want, and you can see the loss of data compared to the NED. So there you go, 3 different forms of data importing. Next, what I want to do is show you how to stitch, because sometimes the seamless NED data comes in larger quadrangle areas that you have to stitch together. Basically, it's really not a quadrangle. It's chunks of 100 megabytes or more get stitched together. So if it's an image that's 100 megabytes or less, it'll be fine. But if you have the original stitching data that we have from the first download of the original DEM data, Then we'll have to stitch it together, and I'll show you how to do that. But first, let me talk a little bit more about the selection set here. Selection sets with 386, a measurement of 386 or less, result in a 256 resolution map in Terragen. Dems with a resolution of 384 to 768 result in a 512 map in Terragen. Dem maps of 768 to 1535 result in Terragen width maps of 1024. Dem widths of 1536 to 3071 make a 240 or 2048 Terragen map. Dems with a width greater than 3072 make a Terragen width map of 4096. So things to think about, and here's where our measurements occur. Another hotkey to get to it is by pressing the F8 button. Actually, it's the Control F8 brings up the matrix size, and those are the sizes that I had just talked about, so that you can get your image to correspond. So right now I'm changing it to up into 380 just for fun, which gives us a terrain width of 256 in Terragen. There we go. So let's try that one. That's a sample export. Whoops. And then open Terragen. And open up our export. There we go. Let's see how that looks. Oh, much better. Double check our size. 257. Change our grid points once we know that that's what that is. And there we go, a larger render of a bump in the ground. Okay, so in the next one we're going to take a look here at stitching together those larger maps, those quadro maps that we put together with 3D Dem. So, okay, so we're going to open up 3D Dem again, and what we have to do is open and convert all of our files to an ASCII Dem. So let's open up create a new folder. Well, here we'll just start at the top. Here's our first one. Save it as an ASCII Dem, create a new folder. Okay. Okay, now we select Load Train Model, USGS DEM, open the folder, hold down the Shift key, select them all, and open. There we go. It has stitched them all together into one gigantic map for us. So let's take a look at a preview here. No, that's just the selected area. Move the selected area, get a preview. It's going to take a minute, and there it is. Let's take a look at this little feature right here. Let's zoom into that. There we go. Alright. That's how you stitch together images for export. And again, here's our matrix size, so we can figure out what size we want for export to Terragen. Oh, that's a nice feature too, and also in 3D DEM is you can right-click and draw a line and get an elevation profile of what you're exporting. Okay, so I'm going to export that as I'm going to export this as a Terragen file, put it over the test, sure, and go back to Terragen, load it up, set up a camera real quick. Yep, there it is. Let's move our camera a little closer. There we go, and I have visions of mashed potato mountains and creepy little UFOs flying around here. Thank you, Mr. Spielberg, for making my life so colorful. So we're rendering out the image real fast just to get a good image of there it is. Detail still needs to be applied to it, but that's elevation data of Devil Mountain in Wyoming. So I hope you've enjoyed this little tutorial on stitching together terrain maps and working with elevation data in Terragen. Again, here you can export to any of your favorite gigantic 3D packages, Lightwave, Maya, Blender, and texture away. Alright.